Now, after that course scheduling problem, I've also solved this. Its second part. And problem statement is also similar, but we have need to do one different thing. We need to return the order of courses you should take to finish all the courses. Means we have to return the order of courses here. We need to return here the topological sort because of the directed graph. So in that directed graph, topological sorting is possible. So we need to return the order of courses. And if there are many valid answers, return any of them. Means any one of them. If it is impossible to finish all courses, then return an empty array. Means when cycle is present there, then we need to return the empty vector. It is simple. This is its example. The total of the courses to take course one. This is the example explained in these are the constraints given to us. Prerequisite dot length. This is also a vector, I guess. Its length is num num course. Num course is basically vertices or nodes. So n into n minus 1. It can prerequisite vector can go to maximum length n into n minus 1. And we have seen this are both nodes should be different and all the pair are distinct. Now I'll go on the explanation part. The main function that is given to us for implementation was this find order function. Here what we did initially was we made bool visited vector. So inside it we passed the no n, and this is 2D vector edges. We passed it. This information is basically given in input. Now what we done is we made the visited array marked all falses. This thing you know, and after this we made our answer vector. This vector which we have to return. That's why we created this vector, and we will return it at the end. This is empty answer vector, which is courses vector that we return at the end. We made it of integer type because we have to return the number of courses. Now we run our for loop on all the nodes. Integer equal to 0 less than n plus plus. If node, since we are run on I nodes, so if our neighbor is not visited, so it can be taken as I, not bool this time, because we are running taking I pointer. Inside this, if it is not visited, so we have called this function is cyclic DFS, and here we have made this as I as, as our new source, which was not visited earlier, and marked it. This source as visited and called for recursive path and edges. These parameters are necessary. These parameters have been passed because this parameter has been passed because these parameters are necessary to code the logic inside this function. And if cycle is since we have a cycle present, that's why we made this empty vector and there is cycle present. That's why we return that empty vector. Now after the end of this for loop, we made the step and reassign all the values. False, all the node value of this visited vector. We have assign means reinitialize all the nodes value to false. This visited vector. Again, we are reinitializing visited vector to false. Because here we took the stack data structures. We have already implemented stack in some past problem. We again run the loop all on all the nodes, and if neighbor is not visited, then we call the topos logical order and mark it as visited. Mark that I node as visited and push the stack call for stack and edges, and we run the while loop on our stack when until and unless it gets empty. So what we are doing here is that in the stack, from the top of that stack, we are just pushing our value to our answer vector, which was empty at that time. Okay, then we are copying the values from the top of the stack. We are pushing the value from stack to that empty answer vector, and we are just popping all the values from the stack. Means we are making stack empty and storing the topological sorting order in our answer vector. To make it, we store the topological order inside that vector. Earlier, that answer vector was empty, so we will return that answer vector, which has stored the top, topological order. Now I will explain you my custom function that I wrote after that main function. This is the cyclic DFS function. We are using it from many times. In this function, we write the logic to detect cycle and directed graph. Inside this function, we pass our source and visited by reference and recursive path and 2D 2D vector or 2D array edges. This is generally empty 2D vectors, I guess. And this is obvious thing. And this part we did in its course. This loop we have run on all the edges on our course schedule part 1 problem. And this is again also a similar logic. Okay, so I've explained this function. Now I will explain you this second function. This second function logic here is different in the course schedule part 2 problem. We need to return here the topological sorted. The logic of this function is topological sorting. We have passed the source, visited, stack, and the edges. This four parameters is necessary. We have passed this 4 parameter because these 4 parameters are needed to take out this topological sorting order. Now initially we will mark all the source node in the visited array to be true and run the loop on the edges, and we did that similar logic. Now instead of calling this cyclic DFS, we call pickle order function. If here v is not visited, so we will mark the v here source, and we mark this source is visited, and we call it for stack and edges. So at the end of this for loop, after the end of this for loop, we pass the source on to the stack. Source means all the nodes in the stack, which was the order of topological sort, I guess. Just try to drive in. The time complexity here is big of V plus E. Nodes or nodes that is vertices. So vertices plus E. Edges. Node plus edges. That we are not called as is cyclic DFS because we are inside the topological order function. So we have called for it.